Hi, welcome back to LeetCode. In this we discuss LeetCode problem 802. Find eventual safe states. So the problem statement that there is a directed graph of n nodes with each node leveled from 0 to n minus 1. The graph is represented by a zero index 2D integer array graph, where graph I is an integer array of nodes adjacent to node I, meaning there is an edge from node I to each node in the graph I. This is directed graph, and suppose we actually have three nodes, so the nodes will be 0 1 2, right? 0 to n minus 1. And now suppose graph I means graph 0 node contain only 1 and 2, so that means there is an edge from node 0 to 1 and there is an edge from 0 to 2. Okay, this is clear. Till this statement is clear. Next is a node is a terminal node if there are no outgoing edges, and a node is a safe node if every possible path starting from that node leads to a terminal node or another safe node. So return an array containing all the safe nodes in the graph. Return the answer should be sorted in ascending order. Suppose our nodes which are actually safe node, suppose we get 1 3 0, so we have to return our answer as 0 1 3. This is sorted, so it return in sorted order. And what is safe node? Safe node is saying that they ultimately which are actually node ultimately, suppose 0 1 2, so there is no outgoing edge for suppose 2, and there is an outgoing edge for 0 to 1 to 2 and 0 to 2. Okay, now who's your first they are saying that safe node will be ultimately reach to terminal node ultimately, right? And if you already get in the path, if you get already one safe node, that will be actually a safe node, right? Ultimately reach to the terminal node, or it is reaching a safe node. So suppose what will be the terminal node here? First we have to find out what is the terminal node. So terminal node, they mention that node that there are no outgoing edges. So which node actually don't have any outgoing edges? 2. So 2 is our terminal node. This is our terminal node. Now which will be safe node? Safe node, they are mentioning that the node or the path starting from that node actually ultimately reaching to a terminal node or is another safe node. So this node 1, there is an edge from 1 to 2, so there is only one path, so this is going to a terminal node because 2 is a terminal node already we find out. So this will be also a safe node, right? Now we will find out the node 0. What is the edge? Edge is going from 0 to 2, so 2 is a terminal node, another terminal node, so this will be also only one path is present from 0 to there is only one edge that is outgoing from node 0, so this will be also a safe node. So what will the answer for this? 0 1 2, right? Terminal node will be always answer safe node, and another safe node will be that will be reaching to a terminal node. Suppose now our graph changes like this: 0 1 2, so there is an edge from 1 to 2 and 1 to 0. Okay, and from 0 to 2. Okay, now 2, what will be the terminal node? First terminal node will be 2 because there is no outgoing edge, so this will be terminal node. Now for node 1, what is the outgoing edges? Actually it have path, so there is one path. Okay, this is a reaching a terminal node, so this is actually it is a okay, but we have to check all the path. So first then another path, there is another outgoing edge from 1 to 0. Okay, so we have not calculated any 0, so first we will check the 0 is a terminal safe node or not. So I'll check what is the outgoing edges from node 0. So there is only one outgoing edge, so this is reaching to 2, so this is a terminal node, so this is also a safe node. Now for this edge we have not finalized that this is actually reaching a safe node or terminal node or not. So we'll say that, okay, this is reaching a safe node, so we'll also case in that this is also a terminal node, so ultimately this will be a safe node, alright? So all are actually safe node. Clear? Now go to the example that actually given in the question. So for this 0, 1, 2, 3, 4, 5, 6. So first of all, we will find out what is the terminal node, which is the terminal node, right? That will be easy. Then we'll check that which node actually going to that terminal node. That will be safe node. So what actually node actually don't have any outgoing edge. This will be a terminal node. This is clear. 5 also terminal node because there is no outgoing edge. 4 also have outgoing edge, so this will not an initial terminal node. 3 also have a outgoing edge. Yes. 2 also have outgoing edge, and 1 also have outgoing edge. 0 also have outgoing edge. So initially 5 and 6 are the terminal node. Now which node will be the safe node? Next safe node. That actually like there is another node 4. So this is there is only one edge. Okay, so this is reaching 5. So 5 is terminal node. So this is actually another safe node. We got it because there is only one outgoing path. Now next is suppose 3. So node 3. So I actually got it going to only one outgoing edge, that is going to 0. Okay, so we have not calculated yet the node 0 is actually safe node or not. So how actually we can first calculate that 0 is safe or not. So how will you check outgoing edges? There are 2 outgoing edges for node 0. One is reaching 1 and another reaching 2. So first we have to calculate node 1 and node 2. So node 1 is reaching where? 2. Okay, now we have to calculate first node 2 is safe or not. Okay, so there is only one outgoing edge from 2, that is going to 5. So this is a terminal node. So this will be a 2 will be safe node. So this is returning edge reaching a safe node. Now there is one another outgoing path that is reaching to 3. Okay, 3. So I have already visited this edge. So what I'll do, I'll check. Okay, this is a circle, right? You can check this is a circular cyclic graph because you can see that first we are what will do, first we are starting from 3, that is reaching 0. From 0 to we are reaching to 1. From 1 to again we are coming to 3. Now 3 again we are going to 0. So what will be, this will be a part of a safe node? No. Why? Because this path, this is one another path, right? They mention that all the paths should be, whatever the path actually have, that should be reached to a terminal node or another safe node. But this path, for this path, from starting from this, then 3 to 0, then 0 to 1, then 1 to 3. This will be one possible path that is starting from node 3 to node 3. So this path is a, whatever actually node is present in this path, that will be not a part of the safe node because this path is not going to any safe node or terminal node. So this should be a false. This should be a not a safe node. 0 will be not a safe node. 1 will so be a safe node. Got it? And 2 also I have already marked this as a safe node because 2 is ultimately going to a terminal node 5. Got it? So that's why this is safe node. Now which node actually we have not decided yet. 0 I have already decided this is not safe. 1 also I have decided not safe. 2 I have decided safe. 3 also not safe. 4 I have already safe. 5 a terminal node and 6 a terminal node. So our answer will be what? This I have to return the answer in sorted order. So first I have to set see that 2 is a safe node. So I have to return true. 2. Then 3 is not a safe. 4 is a safe. So I return 4. Next is 5 is terminal node. 5 terminal node also is safe node. They mentioned the 5 will be our answer. Then next is 6. Got it? Next is this is clear. Now example 2. So 0, 1, 2, 3. How many graph actually node are present? 0, 1, 2, 3, 4. 5 node actually present. Now edges from 0 to what actually I can reach? 0 to 1, then 0 to 2, then 0 to 3, then 0 to 4. Next is from where from 1 I can reach to 1 and then 1 to 2. Then from 2 I can reach 3 and 2 to 4. Now 3 I can reach to 0. From 3 I can reach to 0, and 3 to 4, and 4 there is no outgoing edges. Okay, so first of all we have to find out what is the terminal node. Then we'll check which node actually going to the ending at the terminal node, right? That will be easy to understand. First of all, find out what is the terminal node, which node the terminal. So which node actually don't have any outgoing edges. This node actually have outgoing edges. 1 also have, 2 also have, 3 also have, 4 actually do not have any outgoing edges. So this will be a terminal node. Now I'll check that which node are ending here or have path here. So first of all 3. Okay, 3 actually have 2 outgoing edges. One is reaching to 0, one is to 4. So this is path is safe node, safe path is ending at the terminal node. So this path from 3 to 0, this I have to calculate. So 0 I have not yet decided this is safe or not. So I will first check the 0. So 0, this path is going to 4. So this is a safe. There is another path from 0 to 3. This is a cycle. Right? This is cycle. 3 to 0, again 0 to 3. So this will be not a this path will be not a ending at the terminal node or any safe node. So this will be a discard. 0 and 2 both will be discarded. Both can decide that this is not a part of the safe node. Now next is remaining 2. 2, this path is not going to this any safe node. So this path is not ending. So any one of this node is not any one path is not going to a safe node. Then this will be not also a safe node. So 2, this path is 2 to 3. This path actually I have, and 3 is not a safe node. So this should be not a safe node also. For 1 also is ending at the there is a path from 1 to 2. So this will be not a safe node, right? So I have already decided all the nodes which actually safe or not safe, and ultimately we have actually have only 4. So I have return 4 only. This is clear. Now how actually can solve this problem? So what actually we are doing here? First of all, we are finding out that which are actually first find about the terminal nodes, right? Then we are checking that which nodes are actually coming. There is edge from that node to the terminal nodes. So that will be next safe node. So to find out the terminal nodes, what actually I can do? Which node actually have out degree? Out degree means how many actually edges are there, outgoing edges are there from that node. That should be 0. Out degree should be 0. Or we can say that if this is the one possible. Next, what to do? We will check next nodes that have edges to this terminal nodes. They will be the next safe nodes, right? So I'll check. So how actually can do that? The next nodes that actually have edges to this terminal node. So that actually we can do if we reverse the edges. Then what will happen? Then if I reverse the edges, then this statement will be changes to in degree of the terminal node should be 0. In degree that time will be 0 if I reverse all the edges. Suppose 0, 1, 2. So this is the suppose the input graph, input structure. Now if I reverse the edges, then what will happen? This will be the reverse edge, this will be the reverse edge. Now you can see that in degree of the terminal node, this is the actual terminal node in the input graph. Now they are actually deciding by checking the out degree of that current node is 0 or not. If we reverse the edges, then we will decide by using that their in degree of that node will be 0. Correct? So this is now our one terminal node 2. Now what I will do? I will check the next whatever the outgoing edges actually I have from this terminal node, that should be processed. So that should be the next safe node. So what I will do? I will just decrease the in degree of this current node will be decreased by 1. Initially it is 1. Now if I have processed this, so next the available nodes will be this in degree will 0 because I have already processed this. So this will be the, here actually we are using the reverse topological sort. Now this is the next safe node, because there is only one edge from, that is from terminal node to this node, one edge, and this they mentioned that all the paths we have processed. Suppose there are actually two paths. Suppose, so after this the in degree should, initially it will be 2, in degree should be 2 for node 1, and after processing this edge it will be 1, and after processing this edge it will be ultimately 0. In degree of node 1 will be 0. Now it will, when it will be 0, then it will be the safe node. Then I can say this is safe. So we'll say that when that in degree of any node is 0, then it will be the next safe node, right? Got it? Now then how actually I can handling the cyclic graph here. So suppose we have 0, 1, 2, and there are actually another 1 to 0, suppose. So first of all, what we do, we will reverse the edges. So reverse edges will be what, from this, previously it was 1 to 2, it will be now 2 to 1, and this is another edges. So previously it was 0 to 1, it will be 1 to 0, and this edge was 1 to 0, it will be 0 to 1 now. Okay, now in degree of this it will be 0. In degree of 1 is how many in degree? 2. Here in degree is 1, right? Now, so what will be the terminal node? Initial terminal node will be in degree is 0. So initially we actually have 2. So I will check how what are the edges actually I have. So actually I have 2 to 1. So what will do? I will process this edge and I will decrease the in degree by 1. So in degree I actually have currently 1. So this is not yet we can't actually say this is a safe node currently, because it still actually I have one edge that is coming here. So what we'll do next, I'll check is there any outgoing edge from node 2? No. So you can check that in our queue there will be no new node will be added. So that's why only 2 will be in our answer. 2 will, we can say that this is safe. But how actually handling the cyclic loop in the data graph in by this problem, for this problem. Alright, this is clear. So now go to the code. So first of all, we are just creating a new adjacent list. I should find out the number of nodes actually I have, and I am creating that n nodes adjacent list. And initially in degree of n nodes will be 0. I have initially this is 0, and now I am traversing the input graph list. Alright, so what will get? I will get the node number. They mention that graph 0 represent the nodes. The graph 0 represent there is an edge from node 0 to or I to graph I. So this is our node number, means U, and V will be what? Graph I. So I am iterating one by one. So I am reversing this the edge. So what will happen? I will insert this edge as adjacent of V, pushback of I. So in the V node there will be an outgoing edge towards I. Got it? Previously it was I to V, now it will be V to I. Got it? And in degree of I will be increased by 1, because there is an, I am now reversing. So in degree of I will be increased by 1. So I have taken a queue. So you all know all about the topological sort. So initially I will take a queue, and what will be the node? So I will check the in degree vector, and whatever the node actually I have in degree as 0, that will be our terminal node. I have already explained how actually I am getting this. Now I will insert this into the queue. If the current node I as in degree is 0, so this is a terminal node. I will insert this into the queue. Now what I will do? I will just mark n node as a initially false. False means safe or not. So this will be our safe node, the whatever the actually terminal node. So I am just iterating the queue till our queue is not empty. I am just popping the front node and I am marking this as a true. Means whatever the node is present in the queue, that means this is actually a safe node or terminal node. So I'm marking this as true, and I'm now iterating all the adjacent node of the current node actually I have. So I'll just processing each by each one by one edge. So the in degree of v will be decreased by 1, and if the in degree of the v u to v, that v is equal to 0, that means this node actually ultimately reaching to a terminal node. All the path actually are reaching to a terminal node. So that time I will actually insert this into the queue. Got it? When actually insert in the queue, and whatever the actually value actually present in the queue, whatever the nodes present in the queue, that always will be a safe node, because I am inserting when actually processing all the outgoing edges, ultimately actual outgoing edges as an ingoing, means I have already reversed all the edges. So suppose this node actually have so many outgoing edges. So ultimately we have, this is a terminal node. Now I have reversed all the edges, right? So what will happen if I reverse this? So this will actually have so many incoming edge, right? Now if I, after processing all the edges, then I am saying that this is in degree 0. That means what? I have started from terminal node. Now I have reached this node that I have processed all the edges, and it is coming here. That means what? This is ultimately a safe node, because whatever the actually node path actually I have, that is ultimately reaching to a terminal node, right? All the path is reaching to terminal node, and whenever I have reversed this, that's why whenever in degree is 0, that means I am coming to this node from terminal node, because I have started from terminal node. So that time I am inserting into the queue. Now I have written the answer vector. We are expecting a vector of integer. So they mentioned that I have written the sorted order. So I am just again traversing this each say vector, where actually I will traverse from 0 to n minus 1, and whatever is actually true, whenever it mark as true, that means that current node is actually as safe. So I will check is safe of the current value is I is equal to true. Then I will insert the current node into the answer vector, and I will return the answer. Got it? So if you like the expressions, please like the video, and if not yet subscribe, please subscribe the channel. Thank you.